Right, 1.8. Which of these variables will correctly count the number of digits in the string SNU? Okay. Which one will correctly count the number of string digits? Okay, so we're only looking for digits. Okay, so let's assume we had a string. Okay, as I say, let's use an example. And sort of a mixture of the good and the bad. In other words, something with digits in and characters and capital. Let's just see if it works with everything there. And we're saying, right, for, and that's called SNU, by the way, that thing. So we're saying, right, for, let's do the first one, for, if the loop equals, okay, this one bothers me because here I'm testing pos, and it looks like that pos actually might work. The first part anyway, but I'm testing if it's equal to naught. What does it mean when pos comes back with a naught? It says, sorry, I did a search and rescue, and sorry, I couldn't find your friend. Okay, he's not there. Okay, she's not there. So that one we're going to discard because that one's looking for equal to naught. He has another greater than equal to naught, so just that. So I'm just trying to show some tactics that you can also have by spotting the baddies, and then you're kind of left with the good suspects, because the baddies are all gone. Okay, so we can kick that one out because that's testing equal to naught, so that's not going to find a match. That'll find, in fact, quite the opposite when it's not a match. This one's saying, okay, find it when it's a match and when it's not a match, because when it's greater than naught, it means that it's found, and when it's equal to naught means it's not found. So we're checking out C and A. Okay, sorry for anybody who shops there, but okay, C and A, Central News Agency, many years ago. Okay, so we're left with these other ones down here. Okay, let's just check which of these would possibly work. Okay, so yeah, I've got for I equals loop. Then if the pos of the new loop, oh, that's a sneaky one there. It's checking. It looked right to me, but look, it's checking there each character. So it's going to take the 1, the 2, the 3, the 4, the A, and the B, and the star, and it's checking if it's a digit. But they left off the 9. They left off the 9, so those 3 are now goners. Okay, so let's double check if we're quite happy with number D. It goes from 1 to the length of it, in other words, through every character, and it checks if it's in the range 0 to 9. Okay, please notice that you can do two different. If I put a 9 in over here, okay, if I put a 9 over here in B, then that would have been a perfectly acceptable answer. Okay, but unfortunately, it's highlighted. Okay, if I put that 9 in there, or that 9 appeared, it would have been okay. So if you look at number B and number D, there are two different ways of checking and doing exactly the same thing. Okay, and that you're going to get used to because we're going to have some practice of that just now. So the one uses the pos method, says, right, is this character in the string? And the other one says, right, is this character in the set? Okay, and there's sometimes no particular way of deciding which way you want to do it. Other times, depending on circumstances, one method might be easier than another. Okay, question 1.9 is ask you to check on a landline number which has generally got 7 digits, no other characters. So it's, for example, 041-364-1214, whatever it happens to be. So I'm going to use that as my example and install it in SNUM. Okay, so it looks pretty standard. It looks like all of the examples. There's nothing strange going on for the first part. They're all starting with the correct loop for loop equals 1 to the length of, because they want to go through each character in that string. Remember, SNUM is like the big block, and SNUM square brackets are the little compartments in it, like the block of flats we said. So I can refer to the whole thing or each individual one, which is this is what this is doing here. So everything right to the first part there is the same in all the examples. So I don't have to freak out. It's what happens after that. Okay, that after the if, in the if statement, that becomes a little bit different. Okay, this looks fine. It's going through each one. It's checking if it's a digit, and if it's equal, it increments the count, and it counts if there's 7 digits, then, and which is 1, 2, 3, 4, 5. There are 7 digits, then it shows that it's valid or it's not valid. Okay. This one is, so I'm thinking A is the answer there. This one, if the length is equal to 7, no, that's not necessarily true, because just because the length is equal to 7 doesn't mean there were digits in there. I could have had a letter in there as well, so that one's definitely gone. Right. Okay, now's the time when you start to think, okay, well, let's not just think of an example that is correct. In other words, like 364. What happens if I had something else in there? I don't know, what somebody had a letter in there at the end or something? Okay. Would this first one work if they had an extra digit? Yes, it would, because it checks for 7 digits, and if it's not 7 digits, in other words, if it finds 8 digits, then it's still going to show invalid. Okay, but what happens if I sort of hoid a letter there at the end? This thing is going to correctly go through and count 7 digits, but it's still going to tell me it's valid because it's found 7 digits, but there's a bit of a problem here. Okay, a bit of a problem there. That horrible thing at the end there is going to cause it not to be a valid number. So there's actually 2 things that I need to check for here. I need to check that there are 7 characters in there only, and that all 7 characters are digits. Okay, and that's sometimes the example when you choose an example that's perfect. So sometimes choose the one that's like got all the funny little variations and say, okay, do you still work? Okay, try me. Okay, you work for this case, but you don't work for that case. Okay, try me, baby. Come on. Okay, let's take it up a notch. Right. Please don't play these videos to your parents. Okay, there we go. So that one's not going to work. Okay, so number A is out. So we're looking for something that both checks the length of this being equal to 7 and the number of digits. This one worked out the number of digits. That's not a problem. Okay, so we're looking for something with, okay, now there's 2 down here with, okay, that one's not going to work either because that's just checking the length. So we're down to these 2, and they look quite promising because they both check if the length is equal to 7, and they both check that there are 7 digits, because our count can only be 7 when there are 7 digits. So they both look as if they work, so one of them is wrong. Okay, check what's happening here again. This whole thing has come up in a few examples now. Okay, that makes no sense, because equal to 0 means it's not found, but greater than 0 means, so irrespective of whether it's greater than 0 or equal to 0, in other words, whether it is found or not found, it's still going to increment the count. Okay, so that doesn't make any sense. You'd either be testing equal to 0 or greater than 0, depending on what you're looking for, if you're looking for it or not looking for it, if you can put it that way. So this one should work. Okay, let's have a look at this one here. If the length of this incorrect one is 7, no, it won't be. It'll be equal to 8. Okay, but let's think of it for a valid one. The length will be equal to 7, and the count, because it goes through each individual character and adds on 1 every time it finds a digit. So if both those things are true, then it's valid. Okay, and that's sometimes the big problem we have in programming. We program for the correct examples, or the ones that are not going to throw us, because we don't think, because naturally, I mean, we know what a landline number is, okay, but we need to have it for all possibilities that it works. Okay, and finally 1.10, and you're probably just looking at the code thinking, holy schmoly, that's just too much for me, I'm just going to guess C. Okay, no, don't do that. Okay, let's have a look at the question first of all, and then we can decide whether we're going to ship out or not. Which of these 4 loops will correctly check if it's valid in terms of it must contain no letters of the alphabet? Okay, uppercase or lowercase. Okay. Right. Must contain no letters of the alphabet. Okay. Or digits. Oh my word, I didn't see that part there. Or digits. Okay, so or digits as well. So it would only be valid if it had funny characters like exclamation marks and @ signs and hashtags and all those type of things. Okay. Right. Well, look, this part's always pretty standard. Okay, so that just means go through every character. And this is checking if it's in 0 to 9 or if it's in A to Z, so small letters of the alphabet, and A to Z, and then it's incrementing the count. But is that what I actually want? Well, it depends on how we test it afterwards, because this is quite clever. They check if the count's still equal to 0. So before this loop, we can correctly assume that our count was set equal to 0. In other words, if it goes through every character and it doesn't ever find a match to 0 to 9 or little a to z or big A to Z, okay, if that never happens for any of them, then our count's going to end up still being equal to 0. As soon as it finds one of them, it's going to say, okay, I'm going to increment the count. Okay, and we said it mustn't contain. So this is a clever one. This is a clever one, because it's saying, right, if our count remains unaltered, in other words, we never found a digit, we never found a lowercase letter, and we never found an uppercase letter. So I'm thinking A is the correct one. Okay, yeah, because B is the wrong way around. Okay, B is the wrong way around. If you think about it, because they're saying if our count is equal, if it's equal to, okay, that would check, this would only be true if every single, first of all, it's not checking for, okay, straight away I can actually reject it. It's not even checking for lowercase, so I'm not going to bother about that one. Okay, this one was looking a little bit better. But the check after it comes out of that loop says if the length of S new is equal to 0. In other words, we're saying there were no characters in the string to start off with. Okay, well that's silly. Okay, that's not going to apply. So what was the other one that we possibly had as an issue here? Okay, this one's checking, and then it's checking if it's less than or equal to, no. What this is doing, it's counting every time it finds a digit or a small letter or a capital letter. So when I come out here, I just want count to be equal to 0. Okay, because I didn't want to find any. Okay, I don't want to find any. I don't want to come out with an answer of 1 or 2 or 3, because that means it's not, it has got digits in it, or it has got letters in it. Okay, so there's some quite stretchy, mindy ones like that. And you can see, I think there was a progression from the beginning of the multiple choice towards the end of the multiple choice. Okay, and so the multiple choice is going to be based on these 10 examples, the previous 10 examples, and those ones that we had in the multiple choice sheet. Okay, they're all bundled up in the folder, in the Teams folder. Okay, but I'll put them all together in a nice little package for you. Right, and that's the multiple choice finished. Finally,